Let's open up a new notebook in Wakari. We're going to be looking in this session at Wikidata. That's data from Wikipedia. It's actually the number of times that a wiki page is accessed per hour. And this is called the Wikilogs data. And we have per hour, per page data since 2007 up to the present. So let's type in from wakaridata.wikilogs import Wikilogs. So this actually creates an access to the data. The data set itself isn't downloaded at this point because it's very, very large. So Wikilogs here creates a class called an adapter that allows us to access the Wikimedia data. If you were to click on that link, you would actually go to the page that describes this. So we're going to look at some of this data. Where it says Wikilog there, that's just the name you gave to the adapter. The name we gave it above was logs, so we put logs and then that access there. Notice we've created an adapter. Now we're going to give this a meaningful name. So this is hour 7, day 7 of April of 2011. And we're going to bind that name to logs and the date and hour reference. Now once we've done that, we don't have to type the entire hour thing again. We can hit the tab key, and the tab key will let us choose, and so we'll just complete it. So we're going to create an array out of this adapter by taking all the contents, that's the colon that's inside of the square bracket. We'll take all the contents of the adapter and we're going to make it into an array. An array is just like a huge matrix. So it's going to take a minute. As a matter of fact, you might want to get a paid account for this course. Of course, for undergraduate courses, I just let them use the free account, but the paid account's a lot faster. And at this graduate level course and the size data sets we'll be working with, you might want a paid account. I wouldn't say do it right now, but if things are getting slow and you're getting a little frustrated with the slowness of Wakari, I definitely would recommend that maybe you do the $10 a month plan or something like that. So we've created our array. So this is hour 7, day 7. So this is a single hour of data. So we're going to use the len command, which is the length. And notice that this is 5,587,233 pages. So notice we don't have to type in the entire name. We just type hour and hit the tab key and it completes it. And here's just a sampling of the data. You can see these are the names of wiki pages. And the 1L and 6148L, the L there means long integer. We have to use long integers here because some of these integers can be very, very large. When we print the integers, though, they won't print with the L. They'll just be regular integers. You'll see that momentarily. So what we have is each page, each hour, has a record of how many times it was accessed. So let's look at hour 7, day 7. Notice I didn't have to type the whole thing. We're going to look at field number 2. Now remember, indexing starts at 0. So field 2 is actually where you see the 1L, 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 and that's the number of hits during this particular hour on that given page with that name. So the first page was hit twice in that hour. Most of them were hit once. So let's define another meaningful name, hits during this hour. And again, once we type a little bit of the name, we just hit the tab key. And we're going to assign what we just did to the name hits during hour. So what's the mean number of hits during this hour? Well, 3. So each page was hit on average about 3 times. The median, and notice I hit the tab key to finish the name. I didn't have to type the whole thing. The median's 1. That's not surprising. Most pages are accessed no more than once in an hour. Notice also that they have to be accessed in order to make this measurement. So 1 actually corresponds to 0, and as you can see, we have a histogram that's really not very useful. It just simply shows that most of the pages are not accessed during that hour except to collect this data set. That's why the 1 hit. So we can access hits during hour. Inside the square brackets we can put a condition, and the condition we're going to look at is the number of pages where the hits during the hour is equal to 1. You can see there that the array is all the 1s. So this is all the 1s in our hits during hour data. And notice that there are 3,930,595. So only about 2 million hits during that hour. How many were hit twice? A little under 700,000. So that's actual number of pages accessed in some sense. Is more like several hundred thousand. Notice that only 146 pages were hit 100 times during that hour. So let's look at the histogram again. This time we're going to put a condition on our hits during hour. And notice once again I hit the tab key. And I tab down to, or I scroll down to our hits during the hour. And we're going to look at only pages that were hit fewer than 10,000 times. And the reason for this is very simple. The main page is hit huge numbers of times, like millions each hour. This is a logarithmic scale, and notice in our logarithmic scale with 20 bins, that's the number of bars that we're using. And notice we get this curve. It's somewhat reminiscent of exponential decay or a polynomial decay. But we don't want to leap to conclusions. Notice when we go up to 50,000 that we start getting gaps. We see these gaps where there are some pages that are accessed huge numbers of times, but there are also some pages that are not. And there's a lot of variation in that.